Solving systems by substitution. How do you solve a system using something like substitution? Well, first, before we get into that, let's kind of talk about what these words mean, system and substitution. We know that the word substitution, we use it all the time. In fact, I bet you a lot of you go to Jack in the Box, and when you look up at that menu, you kind of look at different kinds of combo deals. And when you look at a combo deal, you kind of get a burger, fries, and a drink. But what if you don't want a drink? You want a shake. You substitute in for the shake. If you don't want fries, you want onion rings, you substitute in for that. If you don't want a cheeseburger, you would want a chicken sandwich, you're substituting into that. So we substitute on a regular basis. So we understand that substitute means to exchange something or to replace something. So we need to kind of keep that in mind. Now let's remind ourselves about a system of equations. We know that a system is made up of two lines. When we graph each line, for example, this one, y equals 3x plus 1, with this line, y equals negative x plus 5, they're going to collide into each other. This is going to give us the common solution. Now we know that graphing takes a lot of work. We've got to find the slope, we've got to find the y-intercept, we've got to plot it, we've got to count up and over. Well, there's a lot of work involved in that, and there could be some mistakes made. Maybe you did the slope the wrong way. Maybe you don't put the y-intercept in the right place. So there's a lot more mistakes that can be made in graphing. So when we talk about solving systems by substitution, we're talking about doing it through algebra. Now, this is done by using one equation to solve both equations. I know that sounds kind of crazy, but it works really well. If you have a highlighter, this will help out a lot. If you don't, pause the video, grab a highlighter, and then come back and start the video and continue on. So let's take a look here. We have x plus y equals 5 and x equals y plus 1. Now let's think about what these are really telling us, and this is where our highlighter is going to come in. Okay, we see that one variable is sitting by itself, x equals. So what we're going to do is, in place of the x, we're going to drop this y plus 1 in that spot. We're going to replace it. We're going to substitute it. So here, if we think of our combo, we've got three things. And what we can do is one of them can be easily replaced. So what we're going to do is we're going to take this y plus 1 and we're going to put it in that x spot. And we're going to rewrite it over here. So instead of me writing x plus y equals 5, what I'm going to do is I'm going to erase this x, because in that x spot, I'm going to put y plus 1. And I'll put it in parentheses so that we can see that I'm replacing it. Now, hopefully, you guys see is happening is that we can go and solve it like we've been solving equations from Module 7. We have y plus 1 plus y. We can take these and combine like terms. Because I have a y and a y, I have two y's. Plus 1 equals 5. Now we're at a two-step equation. If I subtract 1 from both sides, I will get 2y equals 4. Divide both sides by 2, and I find out that y equals 2. Now we have to remember, just like before when we're solving a system, our answer is always an ordered pair. So since I found the y as being 2, I'm going to drop the 2 in that spot in the ordered pair. Now what I'm missing is the x. So I'm going to go back to the original equations, and I'm going to use this one here. X equals y plus 1. And I'm going to put 2 in place there. I know that x equals 2 plus 1. Well, we know 2 plus 1 is 3, so we know that our solution to the system is 3, 2. Now, once again, this is kind of hard to get used to at first, so using a highlighter is really going to help. What you want to do is highlight what they have in common. I'm going to kind of erase this a little bit more so you can see it one more time, because sometimes I have too many lines going and it gets people confused. But what you see is you have x equals. You see how the x is here? That means you're going to put this y plus 1 in that x spot and just replace it. If you can replace it, then you have just one variable where you can combine like terms and then solve for that one variable, put it in your ordered pair, and then go back and solve for the other variable. Okay, let's try it a couple more times. Here we have y equals x plus 2 and y equals 2x minus 1. So what it's saying is that I have y equals one thing and y equals another. Well, if that's true, if y equals both of these things, then both of these things are equal to each other. So what we're just going to do is rewrite an equation that shows that x plus 2 equals 2x minus 1. Now, we've practiced solving these before. These are variables on both sides. We have a single x and a 2x, so we're going to keep the 2x and we're going to get rid of the single x. So we're going to subtract x from both sides. X take away x is 0. We have 2. 2x take away x is x minus 1. So then we're going to try and isolate that x and get it alone. So we're going to add 1 to both sides. 2 plus 1 is 3. And so far we find out that x equals 3. So in our ordered pair that we're going to build, because we know our answer is always an ordered pair, x will be 3. What we're missing is the y. Now I can choose either of these two equations. I can choose y equals x plus 2 or y equals 2x minus 1. I'm hoping that you realize that this top one is a lot easier. So that's the one we're going to use. We always want to choose the easier one. Put that 3 in the x spot, and we have 3 plus 2, and we find out that y equals 5. So we're going to put a 5 in the spot there, and now we have our ordered pair 3, 5, where these two lines are going to cross. We're going to do it one more time, so I can give you a little bit of everything. I gave you, in our first example here, I gave you what it would be if we had one variable by itself. Here we have two variables by itself. But what happens if we don't have any variables by itself? Here we have 3x plus 4y equals 2 and 2x minus y equals 5. So what we have to do is be a little bit of a detective. And when we take a look at this second equation, we're thinking, hey, if this y was by itself, this would work out great. So what we're going to do is we're going to fix it. So 2x minus y equals 5. And we've had a little bit of practice with this when we were getting our equations ready to graph them. So the first thing we're going to do is we're going to subtract 2x from both sides. We do that. We have 2x take away 2x, which is 0, brings down the negative y. And once again, we're going to put the x term first and then the constant. And again, we have that negative y going on. That's telling us the opposite of. So we know the opposite of y is y, which means we need the opposite of everything else. The opposite of negative 2x is positive 2x, and the opposite of positive 5 is negative 5. Remember, the way we find that is we can divide or multiply everything by negative 1, and what that does is change the signs. Okay. So now let's get back to our highlighters. We found out y equals 2x minus 5. Now remember, we are fixing this equation, which means we can't go back into this one. We can't drop this y in there because this is the equation we fixed. We have to put that y up here. So let's rewrite that equation. We're going to have 3x plus 4, and in place of the y, we're going to put parentheses down, and that y, here we are, we're going to put 2x minus 5 equals 2. Now, you'll notice that it's got a lot to do. We're going to do everything that we've learned about how to do variables on both sides. We're going to distribute, so we're going to keep this 3x. 4 times 2x is 8x. 4 times negative 5 is negative 20, and that all equals 2. Then we're going to combine like terms. We have 3x plus 8x, that's 11x, minus 20 equals 2. We're going to isolate this x variable, so what we're going to do is we're going to add 20 to both sides. That gets rid of the 20. That leaves us just 11x on that left side, and 20 plus 2 is 22. Then we're going to divide both sides by 11. And we find out that x equals 2. So remember, we're building our ordered pair. So far we found out x equals 2. We've got to find the y. So taking a look at either one of these, it doesn't matter which one we go into. It's up to you. But remember, we can't go into this one that we fixed. We have to go back to the beginning. I think most people will pick the second one. So let's see what we come up with there. So if we put 2 times 2 minus a number equals 5. Well, if we simplify this, this will be 4. Take away y equals 5. Then what we'll do is we'll subtract 4 from both sides. That gives us the opposite of y equals 5 take away 4 is 1. Well, if the opposite of y is 1, then we know from previous, just like we spoke about, that means y has to be negative 1. And that negative 1 is what we're going to put in this spot. So the answer to this system is 2, negative 1. It takes a lot of practice to do these types of problems, but my suggestion to you is to look for that single variable. Try and find the single variable. You find the single variable, isolate it, get it by itself. Once it's by itself, you know you can take the other part of it and put it into the original equation. Whether you're getting the x by itself or the y by itself, you would do the exact same steps. It really doesn't matter. Hopefully this helps you in understanding how to solve systems by substitution.